Alright, we're talking about section 5.1.6, graphing a quadratic that is in vertex form. I've got the standard form of a vertex form, y equals a, parentheses x minus h squared plus k. You see hk when we talk about conics in unit 6. Hk is the vertex of a quadratic that is in vertex form. This is also, you see hk sometimes when you graph y equals absolute value of x. You see hk when you do the graph of a circle or a parabola that's in conic form, or an ellipse, or a hyperbola. Those are the four conics. The only one we'll be talking about in unit 6 are circles. So, how are we going to use this information? I've already told you that vertex form is very easy. Here's the breakdown. Write down this example. Y equals 2 x minus 1 squared minus 3. Okay? This is a quadratic that is written in vertex form. Notice how different it is from standard form. Right? Standard form is what we did last week. Ax squared plus bx plus c is standard form. C tells you the y-intercept. A tells you up or down. Negative b over 2a is how we graph. Right? Vertex form is dramatically different. There are three major things that it's telling you right off the bat. This is a. This number out front is a. So in this case, a equals positive 2. If a is positive, the parabola opens up. That's just like standard form. If a is negative, then the parabola opens down. So you don't have to learn anything new. Your eyes simply go right there to in front of the parentheses and you say, is that number positive? If so, the parabola opens up. Everybody do your arms up. The parabola opens up. If that number right there is negative, then the parabola opens down. Okay? That's a piece of cake. That's the first thing that you notice. That's the first thing that your eyes go towards. Then, over here, these two numbers tell us our vertex. This number tells us our x value. This number tells us our y value of our vertex. And that makes sense. Vertex form is going to tell us the vertex of the quadratic. There's only one hiccup. There's only one thing that you have to remember to do. Okay? Everybody look up here. This is negative h, and over here in the vertex it's positive h. What's the difference between negative h and positive h? What happened? Well, you did the opposite. So whatever number is inside the parentheses right here, you have to do the opposite of it, and I put a positive 1 right there. If that number is negative 1, that number is positive 1. We have to do the opposite. We do the opposite of what's inside the parentheses. How about this number right here? What number here? What number goes here? Well, it's k, it's positive k here, and it's positive k here. So we do the same on that number. If that number is negative 3, then this number is negative 3. And that is how we find the vertex of a quadratic written in vertex form. We do the opposite of the number inside the parenthesis, and we do the same of the number outside the parenthesis. Okay? So, real quick, we got y equals negative x plus 5 squared plus 2. What is the vertex? Anybody? Careful now, we're doing this one now. Opposite of this is what? Negative 5. Same of this is what? 2. Positive 2. Does the parabola open up or down?
Down.
Down. All this tells you is that it opens up or down. For now. Okay? It actually tells you a little bit more, but for our intent and purposes, that's all we have to worry about. Alright, how about this one? Y equals 1/2 x minus 7 squared. What is the vertex of that parabola? Very good. 7, 0. Where'd the 0 come from?
Because
There's no number out here. There's no number out here. What does the 1/2 tell you?
Opens up by
That the parabola opens up. Happens to be wide, but that's no big deal. Is this easy?
Yeah.
All right. How about y equals 3x squared? Stumped you. Everybody said it was easy. And just like that, I stumped you. What do you think?
Is it the same thing?
Well, you don't have a number on the outside, right? You don't have a number on the inside. Could I rewrite this like this? Would this be equivalent?
Yep.
Yeah.
Are those two things the same thing?
Yeah.
Yeah, but you're not going to see it written like this. So the vertex is at
0,
0, 0. What's the opposite of 0?
0.
0. The opposite of 0 is 0. Okay, how about this one? Y equals -4 parentheses x minus 3 squared plus 11.
Positive 3, 11.
What's the vertex? Say it again.
Positive 3, 11.
Positive 3, positive 11. Very good. I know it's hard for some of you to see. I'm going to do one more. Y equals x squared minus 4. Y equals, you should be laughing at my squat. You got that on video. Y equals x squared minus 4. What's the vertex on that one?
4 and 0.
Careful.
0, 4.
What's on the inside?
Oh,
There's no parentheses, so it's kind of hard. What's on the inside? 0. What's on the outside? -4. So the vertex is at 0, -4. 0, -4. So if I give you a parabola and it happens to be in vertex form, you can A, tell me whether it opens up or down by looking right there. Then you can tell me the vertex by simply doing the opposite and the same. If you can tell me the vertex and you can tell me up or down, you should have a pretty good chance of graphing. Okay? If you want another level of detail, you might want to find the y-intercept. In standard form, the y-intercept is right there, staring you in the face. All you got to do is look at C. But in vertex form, it requires a little bit more work. Does anybody have an idea about how we might find the y-intercept if it's in vertex form? Yep. Think about it. Think about it. Anybody remember from last year, finding y-intercepts, you let something equal 0?
X equals 0.
Write that down. Everybody write that down. In order to find the y-intercept, in vertex form, let x equal 0. This gives your graph another level of detail. Because if we can find the y-intercept in the mirror point, then we've got 3 points. I'll say it again. To find the y-intercept in vertex form, let x equal 0. All right, let's do one together. Let's find the y-intercept right here. What's our step? What do we do with x?
Let it equal 0.
Let it equal 0. So if this becomes 0, what is 0 minus 1? -1. What's -1 squared? Positive 1. What's positive 1 times 2?
2.
Positive 2. What's 2 minus 3? -1. So if this was our graph, quiet please, our vertex is at 1, -3, 1, -3. There's our vertex. Bless you. There's our axis of symmetry running right down the middle. Our y-intercept is at -1 right there. We know that the parabola opens up because A is positive. So we do our mirror point and we do it right there, and here's our parabola. Is vertex form a lot easier than standard form? It is easier because you don't have as many steps. You don't have to do negative b over 2a. You don't have to take that value and plug it in. Okay? Now let's talk a little bit about max min. Alright? This parabola, we say, has a minimum value. Right? It goes down, down, down. If we read it from left to right, it goes down, 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 down. It hits the vertex at 1, negative 3, and then what does it do? It starts going back up again. Down, 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 down. It hits that point, then it starts going back up again. So in your notes, draw that picture and say minimum. Right? Like this. This is the minimum value of the parabola. On the flip side, if the parabola looks like this, what does it have? It has a maximum value. On your quiz, it's going to say, does the graph have a minimum value or a maximum value? And you got a 50-50 shot. If it looks like a valley, then you say it has a minimum value. If it looks like a mountain, then you say it has a maximum value. Sometimes they want to know the value. What is the minimum value of this graph? It's negative 3 right there. The minimum value of that graph is negative 3. Okay? Questions? Alright, so hold on just a second. Alright, Bree, what's your question?
So the min is up and max is down, basically?
Well, look up on the smartboard. Does that graph have a maximum or a minimum?
Maximum.
It has a maximum value. If I wanted to go a little further, what could I say? What is the maximum value? The maximum value is positive 3 because the vertex, it looks like, is at 3, 3. Oh, that's the one we did. That's the one. All right, so rapid fire. Tell me that max or min?
Min.
It has a minimum value. What is the minimum value?
Negative 3.
Careful. The minimum value is 4. It comes down, 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 down. It hits 4, and what does it do? It starts coming back up. You're looking at the y-axis.
All right.
Max and min looks at the y-axis.
Okay.
In a second. Just kind of shift. I'm doing the camera here. All right, so here we go. Max or min? Minimum. Max or min?
Min.
Everybody should be looking up here.
Minimum.
How about that one?
Minimum.
All right, how about that one?
Max.
It has a maximum value of what?
Negative 2.
Of negative 2, meaning the graph goes up, 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 up. It hits negative 2, and then what does it do? Then it goes back down. So this graph has a maximum value of negative 2. And that's max min. That's easy. All right, so in summary, we talked about vertex form. I gave you the equation of vertex form, right? Y equals A, parentheses, x minus h squared plus k. Right? We talked about what A tells you. A tells you whether the graph opens up or down. We talked about h and k, that's your vertex. You have to remember to do the opposite of the number on the inside, and you have to do the same of the number on the outside. Okay? We also talked about maximum and minimum values, right? Parabolas can either have a maximum value or a minimum value, and that value correlates to the y value of the vertex. They're always the same. Okay? Any questions on any of that?
No.
Yes, ma'am.
So how do you find the intercept?
Oh, well, that's one more thing we talked about. In order to find the y-intercept, if it's in vertex form, you let x equal 0. And then you plug that in and solve. In standard form, it's easy, right? It's just c. But in vertex form, it's a trade-off. Vertex form is easy to find the vertex, but you have to do some work to find the y-intercept. Great question. Anybody else? Anybody else? All right.